In this video, I'm going to show you how to find some unknown values on similar triangles, and I'm also going to show you how to solve word problems involving similar triangles. All right, but first let's find these unknown values. So these problems are interesting because I really have overlapping triangles. That makes it a tiny bit hard to see what's going on. So my recommendation to you is, when you have overlapping triangles, go ahead and draw the triangles separately. It will make everything more obvious and easy. So I like to just trace the triangles. So here is the smaller triangle that I have now copied. I'm going to put this over here. And now I'm going to trace the large triangle. Okay, and I'll put that right here. Okay, let's label these triangles as best we can. So on the small triangle, I see that we have a Z. We have a side Z right here. I see we have this 35-degree angle. Let's get that going. And we have a 9 over here on the right-hand side. Okay, that's what's going on the small triangle. Now oh wait, we also have the X on the bottom. Okay, so that is going to be an X. Wait, I don't like my X very much. All right, that's a little better. Now, what about the large triangle? What's going on? Well, at the top angle, it's still that same 35 degrees, so that's fine. I'm gonna have 35 degrees right here. In the bottom right-hand corner here, it's 88. So let's go ahead and fill that in. And I see in this corner over here, I've got Y degrees. So now that's all my angles. Now, how about the sides? See the 12? That's going to be this side right here. So I can go ahead and mark that with a 12. This line that's stretching all the way, that's showing the length, the full length of this side of the large triangle. So that means that's my 18, which is right here. Now, the only one that takes a tiny bit of thought is this side right here. Is 6 and 9. You have to add those up to get this side. So that's going to be 15. So I'm going to have 15 right here. Now, it's time to pick one of these triangles as new and one as old. It doesn't really matter which one is which, but I'm going to think of this triangle as new and this one as old. It doesn't matter which way you label it, but when you start writing your equations, put them in the form new over old is equal to new over old. Okay, so for example, if I want to find X, let's go after X first. So obviously X and 12 are corresponding sides. In fact, let's just match up all of the corresponding sides. X and 12 are corresponding sides. I see the 9 and the 15 are corresponding sides. And that leaves the Z and the 18. Those are corresponding sides. So let's start with the yellows. And we're going to go new over old. So that'll be X over 12. All right, now I don't want to do the greens next because that would introduce another variable. Let's do the blues. New over old, that's going to be 9 over 15. Now I recommend reducing these. I notice that both of these are divisible by 3. So that means x over 12 is going to equal 3 over 5. If you have any trouble with reducing, don't forget that your calculator will do this for you. Then you cross multiply. So if I multiply this diagonal, I get 5x. If I multiply the other diagonal, that's 3 times 12, which is 36. And then I need to divide both sides by 5. All right, which is going to give me a decimal, which is okay. $7.2. All right, so we found x. Now, how about y? Well, y is an angle. Angles are easy because angles are congruent if we're looking at the different triangles. And within the same triangle, we know that the angles have to add up to 180. So looking at the large triangle, I see that we have both of the other angles, 88, 35. So I'm going to subtract those from 180. That leaves 57 degrees. So that means that y must be 57 degrees. Okay, great. That just leaves z. Well, for z, we're going to do the same deal like we did for x over there. So we're going to do new over old. So new over old would be z over 18. So let's go ahead and set that up. So z over 18 equals. And again, we're going to use the blues for the other side. We're going to use that 9 over 15. All right, new over old. Remember that reduces down to 3/5. So I'm going to have z over 18 is equal to 3/5. And then I'm just going to cross multiply just like before. So if I multiply this diagonal, I get 5z. If I multiply the other diagonal, 3 times 18. All right, so that is 54. And then we need to divide both sides by 5. 10.8. All right, that's it. We found those unknown values, man. Similar triangles. The most important thing, again, is to draw the triangles separately. Let's do the same thing for problem number 14. Let's draw these triangles separately. So, okay, so I'm going to change colors. Got to switch it up. So here's the smaller triangle that I am tracing. All right, I'm just going to put that right here. And now I'm going to trace the larger triangle. Okay, draw the triangles separately. That's the secret. That is the whole secret, people. All right, now let's see what we have got. So on the small triangle, we've got the 9 right here, and we've got the 6 right here. Okay, that is great. Now, for the larger triangle, let me do the easy side first. All right, this bottom side right here is clearly 12. Now, be careful. This is the part that some students find tricky. I need to find this side, the right-hand side of the large triangle. Please understand that the right-hand side of the large triangle is this. So I've got the 9 and the 4x minus 5. So the long side of the triangle is going to be the sum of these two things. All right, so I need to add these somehow. But it's weird, right? How do I add this and this? Well, it'll be more obvious if I write it like this: 4x minus 5 plus 9. All right, I'm adding 4x minus 5 and I'm adding 9. But how do I do that? I just simply combine like terms. You know how to do that. All right, the like terms are the negative 5 and the positive 9. So I just keep the 4x part, but negative 5 and positive 9, that's 4. So I get 4x plus 4. So that's why this side right here is going to be the expression 4x plus 4. All right, you just have to add these up by combining like terms for it, and you get 4x plus 4. Okay, so now pick one triangle to be new and one triangle to be old. Doesn't matter which one is which. What matters is that you write your equations in the form new over old is equal to new over old. Okay, so this is kind of in my way. No, it's okay. I'll just put a line. All right, so new over old. So obviously these are corresponding. The 4x plus 4 and the 9. So I just did new over old corresponding sides. And then that's going to equal the other new over old will be the 12 and the 6. So new over old, that'll be 12 over 6. Both of these are divisible by 6, obviously. So reduce those to make the calculations easier to do. So this will reduce down to 2 over 1. Okay, that's going to just be a lot easier to multiply when I cross multiply. So what can be easier than multiplying by 1? All right, that's way better than having to multiply everything by 6. Keep the number small when you can. So if you multiply by 1, it's just going to stay 4x plus 4. Okay, and when I do the other diagonal, that's 9 times 2, obviously 18. All right, got to subtract 4 from both sides, guys. So that'll be 4x is equal to 14. And got to divide both sides by 4. All right, it's going to be some decimal. 3.5. All right, I think, yeah, that's it. We're just finding the value of x. So that's done. That's done. Okay. Do I need to zoom out? I think I need to zoom out a little for this problem. All right, so we're given triangle FGH is similar to triangle KLM. And then we're given all this stuff, and we're supposed to find stuff. So draw a picture based on this information. All right, so let's just draw some triangles. Okay, so here's one triangle. All right, whoops. All right, and there is another triangle. Okay, so I'm going to separate these out a little bit more. All right, so these are similar triangles. So I'm going to label the first triangle FGH. So this is, I'll just put FGH like that. And the second triangle is KLM. So I'm going to just put those letters in the same order. KLM, just like that. All right, I decided to draw them side by side instead. So what do we have? Angle F is 48 degrees. So this is 48 right there. Angle L is 81 degrees. So that tells me I'm going to have 81 right here. FG is 10. So I'm going to have a 10 right there. FH is 21. So there's a 21 right here. KL is 35. 35. LM is 49. So I have a 49 right here. Okay, so based on this, I need to find all of this stuff. Okay, first of all, the corresponding angles are all going to be congruent. So for example, I see that L is 81. So that tells me that G is also 81. Okay. So G is 81. Boom. I see that angle F is 48, which means that angle K is 48. So that is going to be 48 as well. What about H and M? Well, we know that all of the angles in a triangle have to add up to 180. So let's subtract these two angles from 180. 48 and 81. Okay, that leaves 51 degrees. So these angles must be 51 degrees. So H and M, 51 and 51. Okay, so that just leaves GH and KM. All right, so for GH, I'm going to put an X. And now we need to find that X. And for KM, I'm going to put a Y. Okay, so I'm going to consider this triangle to be new. All right, pick one triangle to be new and one triangle to be old. It doesn't matter which one is which, but when you write your equations, you're going to write them in the form new over old is equal to new over old. Okay, so new over old, so that would be X over 49. And then another new over old would be 10 over 35. Okay, I noticed that these are both divisible by 5. So I'm going to do that. So that's going to give me X over 49 is equal to 2 over 7. If you have any trouble with that, just use your calculator. All right, and then you cross multiply. So if I do this diagonal Okay, that's going to give me 7x. And if I do the other diagonal, that's going to give me 98. So 7x is equal to 98. And then I need to just divide both sides by 7. Okay, and we wind up with x is equal to 14. So that was GH that we just found. So GH is 14. All right, let's do something very similar to find Y. We need to do new over old, so I'm going to do 21 over Y is equal to. Now I can use the same numbers as before. So the 10 and the 35. So 10 over 35. We already know that that reduces down to 2 over 7. So 21 over Y is equal to 2 over 7. So when we cross multiply, I'm going to get 2y is equal to whatever 7 times 21 is. Uh, 147. All right, and then you divide both sides by 2. $73.5. Okay, so that was KM. Okay, so let's finish up with a few word problems. A 6-foot tall man casts a 4-foot long shadow. If a nearby building casts a 54-foot shadow, how tall is the building? Okay, so here's the ground. Well, here's the shadow. So here's the shadow and the man. Okay, so this is going to make a sort of a triangle. The man is 6 feet tall, and his shadow is 4 feet long. Okay, and then there's a building. Let's see, the building casts a 54-foot shadow. All right, so here's the shadow of the building. All right, and then here's the building. Okay, and we want to know how tall is the building. All right, so pick one triangle to be new and one triangle to be old. Doesn't matter which one is which. Just write your equations in the form new over old is equal to new over old. So new over old would be x over 6. And then new over old would be 54 over 4. Reduce these. All right, that's 27 over 2. So x over 6 is equal to 27 over 2. Now cross multiply. So along this diagonal, I'm going to have 2x. And then along the other diagonal, I'm going to have whatever 6 times 27 is. 162. And then if we divide both sides by 2, I get x is 81. Okay, so that means that the building is 81 feet tall. When you're doing a word problem, make sure you include the units. Okay. All right, we're down to the last two problems. An architect designs a building that will be 24 feet long and 40 feet wide. Okay, so here's a schematic of the building. All right, so let's say that this represents the actual building. And the building is 24 feet long. That's weird. Why'd they word it that way? Okay, they said long, but maybe they mean like tall. Anyway, they worded it a little bit weird, but one of the dimensions is 24 feet, and the other dimension, 24 feet, and the other dimension is 40 feet. Okay, but then she makes a scale model that is 18 inches long. So here comes the scale model. Okay, so I guess I really got to stick to the words that they're using. So here's the scale model. So this is going to be smaller. Okay, so they said, I can't switch the words and say tall, even though that would make more sense to me. They said 24 feet long. Okay, so this is the 24 feet long right there. And now we have 18 inches long. So that's going to be this same corresponding side. So I've got 24 feet, and right here I've got 18 inches long. All right, those are corresponding. But the question is, how wide is the scale model? So here we have 40 feet wide. Okay, and down here we're going to have x wide. So pick one to be new and one to be old. It doesn't matter which one is which, as long as you write your equation in the form new over old is equal to new over old. All right, so looking at the width, new over old would be x over 40. Looking at the long side, new over old would be 18 over 24. All right, I like to reduce these down. Both of these are divisible by 6. Okay, now, so I know this is going to be 3 over 4. If that doesn't jump right out at you, just use your calculator. Okay, now cross multiply. So if I multiply this diagonal, I get 4x. And then if I multiply the other diagonal, I'm going to get 120. And if I divide both sides by 4, that's going to give me 30. Okay, so we're supposed to find out how wide it is. Remember, the model is in inches, so don't forget the units. So the model is going to be 30 inches wide. All right, last problem. James is 6 feet tall. When he stands 12 feet away from a flagpole, as you can see, the tip of his 10-foot long shadow is in the same spot as the tip of the flagpole's shadow. So, how tall is the flagpole? Well, really, we have two similar triangles and they are overlapping. So one thing that I've tried to teach you guys is when you have overlapping triangles like this, I want you to draw them separately. So here I'm going to trace the small triangle so I can draw these separately. Okay, so here's the small triangle. Now I'm going to do the same thing and trace the big triangle. Right? Whenever you have overlapping triangles, almost always the best thing to do is to draw them separately. Okay, it just makes it easier to see what's going on. Okay, now let's label the sides of the small triangle. So the small triangle has this vertical length of 6 and this horizontal length of 10. So I have the 6 and the 10. Now, what about the horizontal length of the large triangle? Well, that is 10 plus 12. I got to add these together. It's this whole thing. So that'll be 22. And how tall is the flagpole? So that's what we're trying to find. So that's going to be right here. Let's call that X. So let's go ahead and call one of the triangles new, and we will call one triangle old. It does not matter which one is which, as long as you write your equations in the form new over old is equal to new over old. Okay, so new over old, so that'll be X over 6 is equal to, and then new over old will be 22 over 10. Both of these are divisible by 2, so that's going to give me X over 6 is equal to 11 over 5. And then I cross multiply. So I'm going to get 5x is equal to, and of course 6 times 11 is 66. And finally, we need to divide both sides by 5. And that's 13.2. For word problems, always make sure to include the units.